You can describe a function as even, odd, or neither. So what is an even function? An even function has line symmetry. So if you see the graph, you can determine if it has line symmetry or point symmetry or no symmetry. So even functions have a line symmetry, so a vertical line. You could also test it with an algebraic test because sometimes the graph could be deceiving. So the algebraic test will be foolproof. It will prove whether or not it's even or odd or neither. So what does the algebraic test tell us? Well, when you put a negative x in for x and you simplify it, all the signs should stay the same. You should still have the exact same function with negative x as you would with positive x. So with an odd function, the odd function has point symmetry, which means it's rotating around a point 180 degrees. And if you can't tell from the graph, then you use the algebraic test. And when you put a negative x in for x, you're going to see that all the signs change. And then if you do all of the algebraic test and only some of the signs change, then this would be neither function because there would be no symmetry. So there's not a specific pattern in your graph. It's going to be an irregularly shaped graph. So for this video, we're just going to show how you can use the algebraic test to determine if it's even, odd, or neither. So in example 1, I have f of x equaling 2x squared plus 4x minus 3. I'm going to put in a negative x for x and then simplify it. So this is going to give me 2 times negative x, and we want to make sure the negative x is in parentheses and the exponent's on the outside. And then I have plus 4 times a negative x minus 3. So when I simplify it, I end up with f of negative x equaling negative x squared is x squared times 2 is 2x squared. 4 times negative x is a negative 4x. And then I have a minus 3. So now if I compare this bottom one and this top one, did any of the signs change? So I have 2x squared here, I have 2x squared here. So that stays the same. The middle term, positive 4x and a negative 4x, it changed. And the last term, minus 3 stayed the same. Since some of them changed, but not all of them, this would be neither. Example 2. If I put a negative x in for x, we would have negative x cubed minus 3 times negative x. And then simplify, so f of negative x would equal negative x cubed means negative x times negative x times negative x, which will still give me a negative x cubed. And negative 3 times negative x gives me a positive 3. And now we compare this bottom one to this top one. I have a positive x cubed and a negative x cubed. The signs changed. And then I have a negative 3x and a positive 3x. The last terms changed. So if all the signs changed, that means this is an odd function. And because it's an odd function, we know that this one's going to have point symmetry. And this last one, if I put a negative x in, negative x to the 4th minus 2 times negative x squared. I'm going to get a final answer of f of negative x equaling negative x to the 4th means negative x times negative x times negative x times negative x. That will give us a positive x to the 4th. And then negative 2 times negative x squared is going to give me an x squared times a negative 2 is going to give me a negative 2x squared. My x to the fourth stayed the same, and my negative 2x squared stayed the same. So all the signs stayed the same, so this one would be even, and we would consider this to be having a line symmetry. So that's how you can determine if a function is even, odd, or neither.